Good day, everyone. My name is Denziel Morales, and today I want to present with you my smart detergent scanner, an intelligent mobile application designed to instantly identify and classify laundry detergent products using advanced computer vision, powered by Flutter and TensorFlow Lite. Our system delivers real-time on-device recognition of popular brands like Surf, Ariel with high precision. Key features include an interactive product gallery, a detailed scan history, log, and statistics dashboard to track usage insights, all wrapped in a modern user-friendly interface. So now, let's proceed to my further applications. So to make what does it look like to my further app. So here, in my home screen, I have 10 different classes that I trained and I choose. Each of these have descriptions with their names. So for now, we are going to test our accuracy with our camera scanning. Let's try some products. Let's try this surf calamansi. Let's just wait. Okay. So the results of the scanning is 99.6% identified as surf powder calamansi. Here are the ratings, top 5 results, which is above 90%. Some predictions, surf powder. As you can see, the accuracy of this scanning is quite accurate. So let's try some another products or classes. I'm gonna go with here. Let's scan this. And then, okay, so we have a little problem, but it is accurate as it was. It gives 87.8%. Not bad for a beginner. So let's try it again. Let's focus back. Make sure it was captured properly. Okay. Now the result is 100.0%. You just have to scan it properly. So that it will read as 10 classes. Now let's move on to another features. I have this stats. As you can see, production distribution, so powder to was powder. The tide perfect clean here is my previous scan. So let's go to my history here. As you can see, so powder tawas, so powder calamansi was being recorded to my history. And you can also choose to dark lighting mode, the lights, dark mode, lights mode. So let's back to. our home markets. And also you can share this for the messenger if you want. So let's skip that. So now I'm going to test another pictures from my gallery. So let's try on, let me see, let's try this one. I hope it's accurately scanned. Okay, so not bad. It says 83.3% for sour powder sunfresh. So let's try it again. Our goal is to make higher than 90%. So we try this one. I hope it will. Okay, 100.0%. Not bad. Sour powder antibacterial. For another, okay. So it's good. Now I want to answer some questions with three. So question number one, how can my image classification app be applied to real world scenarios such as education, agriculture, or healthcare? Well, while my leading application currently focus on household products, the underlying technology combining Flutter with on-device TensorFlow interface is highly adaptable to critical sectors without changing the core code structure. In agriculture, by simplifying retraining the model with a dataset or crops. This app could serve as a diagnostic tool for farmers, allowing them to detect plant disease or identify pests offline in remote fields. In education, it could be transformed into an interactive learning aid. For example, students could use it to identify biological specimen in a lab or historical artifacts in a museum, providing instant educational context directly on their devices. In healthcare, it could function as a preliminary screening tool for dermatological conditions or assess visually impaired to for specific medications to prevent data usage error. Essentially, my project demonstrates flexible frameworks where the specific domain logic is encapsulated in a model file. This means we can pivot to this high impact real world scenarios just by creating a new neutral network, making the solution both scalable and versatile. Thank you. So, another questions. What part of the project did you find most technically challenging and how did you overcome it? Well, the most technically challenging part was ensuring accurate image classification with TensorFlow Lite. The main problem was that my model was making incorrect predictions because it would classify image even with low confidence. To solve this, I implement a dual threshold system. The model must have at least 90% confidence in its top prediction, and there must be a 50% confidence gap between first and second predictions. This prevents the app from saving unreliable results. I also faced challenge with image processing. Raw camera image weren't optimized for the model, causing inconsistent results. I built a pre-processing pipeline that crops images to a center square, resizes them to match the model's input dimensions, and normalize pixel values to the range the model expects. This significantly improve accuracy. To overcome these challenges, I conducted extensive testing with different products to find time, the threshold, researched and flow light based practices, and monitored prediction patterns through a statistics dashboard I built. The result is that the app now only saves predictions with 90% or higher confidence, handles various lighting conditions reliably, and provides user with accurate, trustworthy results. This taught me that machine learning integration requires understanding and the entire pipeline, not just loading a model, but optimizing every step from image capture to final prediction. Thank you. So another questions. Last questions. Can you explain the widget structure you use for the homepage, especially in implementing the card style or grid layout for display all identified classes? For the homepage, I use a single child cross scroll view as the parent widget to ensure the entire page is vertically scrollable on a device. The centerpiece of the layout is a grid view builder. I choose this because it efficiently renders items on demand, which is optimized for performance. It relies a silver grid delegate with fixed cross-axis count to identify a fixed two-column layout with consistent spacing between items. Crucially, I set shrink wrap to true and disable the grid's internal scrolling to it scrolls seamlessly as part of the main page. For the individual cards, I designed a custom widget method. Each card is a container style with grounded corners and soft shadow to create modern, elevated look. Internally, I use a column layout with expand widget to strictly divide the space, allocating the top portion for the product image and the bottom for portion the text details. To enhance the user experience, I wrap each card in a twin animation building. This creates a spread in trans animation where items fade in and scale up sequentially when the page loads, giving the application a polished dynamic feel. Thank you. So that's all for the walkthrough of my Flutter app applications. I hope you find it very meaningful to you, and I am thankful for your listening and for your time. Thank you.